So today we're going to talk about expanding or distribution. Essentially, we need to multiply both x and 3 times x plus 5. This is often called distribution, or you may have heard it called FOIL. But what we need to do is multiply x times the x, and we get x squared, and then we multiply x times the 5, and we add 5x. And then we multiply 3 times the x, and we add 3x. And then we multiply 3 times the 5 and add our 15. As we look at the expression that we have, we notice we have like terms 5x and 3x that I can combine. And then we have x squared plus 8x plus 15. This also can be accomplished with an area model. So if I again start with x plus 3 and x plus 5, we can make a rectangle where this is the length of the rectangle and this is the width of the rectangle. So in drawing our rectangle, we have 2 terms for the length. So we split that in half and call that x and 3. And then we have 2 terms for the width. So again, we do x and 5. And then we multiply x times x here is x squared. 3 times x is 3x. 5 times x is 5x. And 5 times 3 is 15. And then again, noticing we get the same thing as we did up here. X squared plus 3x plus 5x, and then plus 15. And then collecting our like terms, you get x squared plus 8x plus 15. Okay, we're going to talk about perfect square patterns. The first perfect square pattern is when we have a plus b and we square it. Now that works out to a squared plus 2 times a times b plus b squared. So we'll start with a simple example, x plus 6 squared. So we see we square the first term, so we have x squared, and then plus 2 times our first term is x, times our second term is 6, and then we add on 6 squared. If we simplify, we multiply 2 times 6, and then times x, so we get 12x, and then we add on 6 squared, which gives us 36. So now we're going to start with a more complicated example. What if my first term is 4x? So I take all of 4x squared, and then I add on 2 times 4x times the second term is 7, and then I add on 7 squared. Now if I square 4x, I have to square 4, so that gives us 16, and then squaring x gives us x squared, and then 2 times 4 is 8, times 7 would give us 56, then bringing on the x term, so 56x, and then plus 7 squared, which gives us 49. So now we're going to look at a second perfect square pattern if I have a minus b squared. And we see it works out to a squared minus 2 times a times b, and then plus b squared. So we'll start with a simple example. Squaring the first term gives us x squared, and then minus 2 times the first term is x, times the second term is 4, and then plus 4, the second term squared. If we simplify a little bit, we get x squared. 2 times 4 is 8, so minus 8x. And then plus 4 squared gives us plus 16. Looking at a more complicated example, if we do the first term here, negative 3x, and then square it. So we have negative 3x squared, and then minus 2 times the first term is negative 3x. And then times the second term is 2. And then we add on 2 squared. Negative 3 squared is 9, so we get 9x squared. Minus 2 times negative 3 is going to give us positive 6, times 2 is going to be plus 12x. And then plus 2 squared is going to add on 4. Now we're going to talk about a different perfect square pattern. If we have a plus b times a minus b, which works out to be a squared minus b squared. So if we're doing x plus 5 times x minus 5, we see that we square the first term, so that gives us x squared. We're adding and then subtracting 5, so then we minus 5 squared, which would give us 25. Looking at a more complicated example, we see that we have negative 6x and then plus 7 and then minus 7. So this is going to work out to be negative 6x squared and then minus 7 squared. If I work that out, negative 6 squared is actually 36. So we would have 36x squared, and then minus 7 squared would be minus 49. So we're now ready to look at some factoring examples. In this first binomial, we see we have 3x squared plus 15x. Now we need to see what we can factor out of the numbers, and we need to see what we can factor out of the x squared and x. Looking at 3 and 15, we can take a common factor of 3 out. So I can pull 3 out of the expression, and then looking at x squared and x, I can pull 1x out. So we're going to take 3x on the outside of the parentheses, and I see that 3x times x would make 3x squared. So the first term would be x, bring the plus sign, 3 times 5 is 15, and then if I multiply by the x, that would give me the x term. So this reduces or factors into 3x times x plus 5. Now, when we have a trinomial of x squared plus 7x plus 6, this is a little bit more difficult to factor, but we look for factors of 6 that are going to sum to 7. So if I just start writing the factors of 6, I have 1 and 6, 2 and 3, and then 3 and 2, and they would repeat. So if I sum them, 1 plus 6 is 7, 2 plus 3 is 5. In looking at the sum, we want the sum to be 7, so this is going to work, and this pair would not. So what we do in factoring this into 2 binomials, the first term is going to be x, because x times x makes x squared. And then these 2 numbers are going to be the second terms. So since this is positive 1 and this is positive 6, I would write plus 1 and plus 6. So now we're going to look at factoring when there's a coefficient in front of x squared. This definitely can be factored. What you need to do is multiply 2 times 9 and we get 18. And then we're going to look for factors of 18 that sum together to be 9. So if I list the factors of 18, we have 1 and 18. That sums to 19, so that's not going to work. We have 2 and 9, which sums to 11. Also not going to work. We have 3 and 6, which sum together to be 9, and this does in fact work. Now, this works a little bit differently than if there was not a coefficient in front of x squared. This is how we break up the x terms to factor by grouping. So what we're going to do is we have 2x squared plus 3x plus 6x and then plus 9. So you see what I did is I broke this 3x and 6x up to make 9x. And then what we do is factor by grouping. Realize that as I look at this, I might have to switch these 2 terms to make it be able to be factored by grouping. But if I look at 2x squared and 3x, and if I factor that, I can factor x out. So this would make x times 2x plus 3. And then if I look at 6x plus 9, I can factor a 3 out. So I would make this plus 3 times x plus 3. And if you notice, there's not a term in here that does in fact work. So I actually need to move these two terms. So if I go 2x squared plus 6x plus 3x plus 9, and then factor from here. Here, I look and I can pull 2x out. So this would be 2x times x plus 3. And then here, I can factor a 3 out. So I would add 3 times x plus 3. Now, I remember this blowing my mind as an algebra student, but you can actually factor x plus 3 out of this expression and bring it to the front. So if I do just that, I would have x plus 3, and then I multiply it by what's left. So I would have 2x left here, a plus sign, and then